Tech Nuggets, iPerf. iPerf is a tool that's part of a network performance testing suite. We would use ping or traceroute to get some basic link information about, client to destination type stuff. Ping and traceroute are very good at laying out binary information like, is it awake on the other end? Is there something there? Do I have a path to wherever I asked to go? That would be traceroute. And it'll also tell you some basic link characteristics like, what's the latency between here and there? How's the lag doing between me and the other end for ping, or me and different hops in traceroute. And that's useful to know latency information, but it doesn't tell you much about bandwidth. What is the bandwidth between here and there? Is it enough to support a voice call? Is it enough to support a video call? Is it enough to support, whatever application I've got that may be a bandwidth hog? How much is my Netflix? It says on the website it requires this. Does my link support enough to be able to do that kind of stuff? Am I getting the performance I paid for is basically what we're talking about. So oftentimes we get a new piece of equipment or we start a new service. We call in and have a new enterprise fiber run. We want to test the link before we start using it to understand the baseline characteristics of what I'm working with. Because without baseline data, you won't know when it goes weird on you. Well, they told me it was going to be a 10 gig link. Did you test it? Are you sure it's a 10 gig link, or did you just believe them? It's often good to go run your own tests. So iPerf's one of those things where we can go run those tests, gather some baseline information. So when things start to go crazy, we can understand what our quality was looking like in our baseline characteristics. Then we can compare it against what's iPerf showing me now and what's ping showing me now. We often use ping and iPerf together. We'll run an iPerf and then we'll run ping at the same time in order to show the latency at the same time that we're looking at the bandwidth in iPerf. So iPerf has a long history. It's a very old tool. Current iteration of iPerf is iPerf 3. Development started in 2014 for iPerf 3, although iPerf is quite a bit older. Comes in a lot of different flavors: Windows, Linux, Mac. You can it's open source. You can download it and compile it anywhere, but there are precompiled binaries for pretty much every OS available. Lots of operating systems and Linux flavors come with it already installed. And it's not hard to get in terms of installing it. Often the package managers will let you pull it right down. iPerf is a unidirectional tool. That's really important to understand. It's only going to test a link in one direction. From the client to the server. And we're going to talk a little more about that in a minute. The types of tests, when we talk about it, are kind of important as well, because standard test from an iPerf is a TCP test. And we do that because it can really flex the bandwidth in the pipe and get a real good feel for how much can I push through this pipe at any one time. And it uses the TCP sliding window to jack up the amount of data that it can send until it can really, push the link to its maximum. And that's a very useful thing. That's primarily what we do with iPerf. But you can use a UDP option on it, and it will push packets at it as fast as it can go. So we can see if we can overwhelm the link with data by just slamming it with data. And that can be occasionally useful as well when you want to understand characteristics of the link and what it's doing and that kind of thing. The basic iPerf setup is a pitcher and a catcher, right? The pitcher, which is our client, is going to throw packets at the catcher, which is the server. Packets are going to go basically in one direction. As a TCP, yes, there are ACKs that come back after the three-way handshake is set up. So there is some return data in the form of ACKs, but it's pretty minimal. And in terms of bandwidth testing, an ACK is teeny, and we're not super worried about that. Unlike ping, iPerf needs to be set up on both sides with different options. And this is where the pitcher and catcher part comes in. And you can see here I've set up the basic server and client, right? Basic server is just iPerf 3-S, and it'll start a server, kind of sit there and wait, do nothing. The client gets set up with the -C option, and then you give it the IP address of your server, and it'll immediately start throwing packets at the other side, and after the test is over, we'll throw out some results for you. Now, there are a lot of assumed in here. How long's the basic test? That kind of stuff. There are a lot of options that we can set up that are really useful to understand and get a little bit more information out of what's going on, because there's many other command line options. One of the easiest ways to get it is just a $? Or iPerf 3 $? Or -H will also barf up some basic this is what it does. I've added the link here for the iPerf documentation. You can go look at it all. It gives great stuff. In Linux, you'd get the man page. Man iPerf 3 would give you lots of information on it. I'll go over a couple here that are some of my personal favorites and tend to be the most useful. Top on my list, -I with a 1. By default, iPerf runs all these tests and you don't see anything or very little. And when it's all done, it barfs out some answers and you're like, oh, it's done. Now, if you're running a 60-second test, that means you sit there staring at a black screen, twiddling your thumbs, wondering, did it die? Has it croaked? What's going on? The -I1, 1 says every second, will put up data on the screen every second. And you can run this on the client or the server. I run it on both. And that way, when you're watching the client and server, you can say, oh yeah, here's the connection and data is coming across. And it'll give you the basic data of what's going on for that time period, for that second. You can set it to 5 seconds or 10 seconds or whatever you want. I believe the default is either none or 10 seconds or something like that. You'd have to play with it to find out. The second one is units. By default, it uses megabytes. And that can be a little disconcerting in networking worlds. I personally prefer bits because a unit of measure doesn't get any smaller than a bit. Bytes can be bytes, and you can argue about that all you want, and I'll leave that for somewhere else. But bits are bits, and no one argues about those. So an F is a format, and B, lowercase b, is bits. There's a lowercase g, which would do gigabits if you're testing really large things, and it'll do the unit translation for you. I often start with bits, especially if it's a very small link and I'm trying to understand, gosh, it keeps reporting 0 every time I look. It must be less than 1,000 basically is what it's telling you. So you need to flip your units to bits, and then it'll start telling you, oh, you get, 60 bits per second. It's a pretty slow link. We talked a little about UDP. This is how you would set up a UDP. -U will do UDP, and the -B option will tell it, don't wait. Throw everything you can at it as fast as you can. So you can bandwidth limit it. If you need to bandwidth limit it, that's what the -B option does. And 0 says, no, thank you. Just throw it as much as you can, and it'll just barf as much data at it as it can. Some of these get combined together. So don't think that they run, I can only have a -I or only have a -F. That's not true. The examples at the bottom here show several great options for, the first one here is a server that's set up for interval 1 and format of bits, and it's running a server. And the second one is a UDP connection that would set up that would, throw UDP packets. I should probably mention the server doesn't care if it's TCP or UDP. It will continue to run. Multiple tests can be run, and you can switch back and forth on the server between UDP and TCP. So you don't really need to specify UDP or TCP on the server. You only have to specify that on the client because it's the one throwing the packets. So that becomes useful. There is a -T option that I did not list here. -T is time. I want a 60-second test. -T space 60. There you go. You get a 60-second test. I think it defaults to 10 seconds, which is usually nice to play around with the command and see how it works. And we'll do that in the demo, and I'll probably show the -T option or something like that. But T can be a very useful option. If you want to see data over time, you may need to run a test for 5 minutes and just slam it for 5 minutes and see what it can do. And there are other places we can get charts and graphs, and I will demonstrate some of that. Well, iPerf will generate all the traffic. There are a number of places you can go in your network, depending on your equipment, to get more data about what's going on in the link. That all being said, let's go on to the practical demonstration, and I will show some of those, iPerf, server, client, how do I get graphs and charts out of this kind of thing? And we'll demo some of that. So we can see here I've got a Windows DOS command window open. And I've already pre-populated it with some options, right? From our slides earlier, I've used the -I, I've used -FB so that I can see bits, and I've set it up to be a client, and we're going to push packets at 10.101.8.7, which is another machine on my network that I've got connected up. Now, what I should tell you is that I've got a 10 gig NIC in my workstation here, and it goes through a 10 gig connection all the way to where this machine is on the other end. And we should be able to get 10 gigs out of it. At least that's what we were told. So let's see what happens. We see it makes a connection. It's going to start pushing data at the other end. And it's telling us in the interval category here that we've got, 1 second intervals, and we could set our intervals for longer. And it's given us a bandwidth in bits per second, which is quite a long number. And if you're good at moving, your 3 digits over, you'll notice it's about 4.5 gigs, 5 gigs, something like that. At the end, it'll actually do the gigabytes per second for us. And it says it's done. So it runs a standard test for about 10 seconds, and we're done. Now, one of the things you can do is you can go in and ask for -G. And if we know the link is going to support gigabit traffic, we can do this kind of stuff. And if it falls under gigabit traffic, it tends to go to like 950 or something like that. It'll fall back to that kind of stuff. And we can see we got basically the same numbers with different units. They're very similar, right? Networks are going to flow. We hesitate to say living things, but there's other things going on, right? There's other stuff going on the other end of the machine, other things on the network. Performance is a very dogs playing pokery kind of thing. Your network is going to vary. Even on a quiet network, it will vary. So you're getting this is a reasonable assumption of what we should see. And again, on a quiet network, if you putting the machine on a bench and you're doing a test run for it to get some nice quiet baseline data, this is pretty reasonable baseline data. However, it's not 10 gigs. So something between me and the other end is keeping it from being that way. And how do I find that out? Well, one of the ways to do it is to start chopping it into pieces. I test, maybe the cable between my machine and I'd have to bring another machine that can do 10 gig quite close. And I can test just that link to see, is it my Ethernet card or the other machine's Ethernet card? And there's a bunch of switches between here and there. And there's a bunch of fiber cable between here and there. We can begin to work our way down the line until we can find the other end. And decide, where is the problem? And we can figure that out. One of the other tests I will run here is we can add a -U and a -B0, and it will sit and throw UDP datagrams at it. You'll notice it's a little bit slower, but it's telling me the total number of datagrams that we're able to throw. So it throws it as fast as it can, runs a 10-second test, and we can see we lost 20% of our datagrams. That's bad. Oh, well, why are we losing datagrams? It's a good question. We can find out. We can look. All right, so I've got my command window open. I've got iPerf set up here, and I've added a new option to the end, which is a -T option for 30 seconds. So the test will run for 30 seconds. And down here at the bottom, you can see I've got the web interface for my 10 gig switch. A bunch of the other information that's behind the command window isn't very useful, so I just covered it up. But what we're looking at is port 14 is the port that's connected to my machine, and port 16 is the 10 gig uplink that goes upstream to where the other side of our iPerf is. So we'll be able to see these graphs, which aren't real time, but are sampled in more or less more often than that. So with a 30-second test, we'll actually get to see the graphs go up and down, and we'll be able to see a little information about it. I will probably do a little time compression on this, just so that you don't have to sit and stare at it for 30 seconds. So let's give it a try. All right, so we can see that the graphs did eventually fill up to about 4.5 or 5 gigs, and they'll slowly sort of unfill as time progresses. So we begin to see some of that kind of stuff. Network monitoring software that we've talked about in other tech nuggets will capture this information. We can see it over time. But this is a good thumbnail way of, if my switches support this or my routers support this, I can go and pull this data off there and say, is it doing what I think it's doing? iPerf lets us fill up the link, but we may have to go somewhere else along the way to see if it's doing what we think it's doing. All right, so here you can see I've got GNS3 set up, and I've got 2 Ubuntu CLIs set up. One's designated as server, the other one's a client. I've got a switch and a NAT, just to give myself a little IP connectivity. Started both of those up, so that way I'd be able to see them. You can see here I've got the CLI for the server up and the CLI for a client up. And I've learned some interesting things about the iPerf 3 for Ubuntu anyway. We were talking about units earlier in some of the other demos. The Windows version used a lowercase b for bits. What I learned was that here you can get kilobits, megabits, gigabits, terabits with lowercase k, lowercase m, lowercase g, lowercase t. And if you want megabytes or kilobytes or kilobits or terabits, you use capital. So a capital K would get you kilobytes. A lowercase k will get you kilobits. And in this, I've set up the same, this is client server. So we're going to start the server. We'll see it's listening there, and it's going to report every second in kilobits per second. Our client is going to report every second in megabits per second. So we'll see it's the same data. It's one test as we go across, but one will report in a different unit than the other. And sometimes that's useful and sometimes that's not. I ran a 3-second test. That was the -T on the end, so it only ran 3 iterations. And if we run it again without the -T, we'll get the normal 10-second test. And we can see there's a number of retries. Again, a longer test is often most useful. A 10-second test is a fairly short test, actually, of anything, but it's good to just see how it goes and starts out. A baseline test would normally be a 60-second, might even be a 5-minute test if you really want to thrash the system and see how it works. And again, we can do things like, I want to do a 20-second test, and we can thrash the system a little harder. Now, in this context, our switch is a virtual switch, right? It's a GNS3 switch. There's no graphs to look at. There's nowhere for me to tell what's going on. We could Wireshark the links and do a little collection of data and get it to show us some bandwidth that it believes that it sees. Unfortunately, with everything being virtual in GNS3, we're going to see some interesting things. The more stress you put on the system CPU-wise, as everything's virtualized here, the slower it may have an impact. So GNS3 is going to be a great environment to test and play with iPerf, but real numbers are kind of a farce at this point as everything's virtualized and all the switches are software constructs and things like that. Again, you'll get some numbers. A real baseline, meh. It's going to depend on whatever the virtual infrastructure is that runs the GNS3 underpinning. In our case, we're a VM. Our client and servers are VMs inside another VM. So you can imagine the recursive virtualization that goes on only adds to the weirdness of actually getting really good numbers out of, iPerf. Well, I thank you for joining me today for our Tech Nugget, and we'll see you for the next one.